All right, here we go. A lot of equations that we see in real life end up in decimals. A lot of times this involves things like money, where you have things like dollars and cents. And so decimal places become important. And we can solve equations with decimals. Sometimes these things look a little ugly, but we can clear decimals by simply moving a decimal point. It's kind of like multiplying by the lowest common multiple. Just remember that every decimal place is like multiplying by 10. Every time you move a decimal, it's like adjusting by a power of 10. So all we really have to do is count decimal places. You can see that this equation here says 0.03j equals 0.6. And a lot of times that decimal will really make things confusing, but we can get rid of the decimal. Count the decimal places. You can see that this decimal has 2 places. This has 2 places. And if you look on the right side, 0.6, it only has 1 decimal place until I get to the end. So we need to know which number is bigger. And so since 2 decimal places is bigger, we are going to move the decimal 2 places on every single term. So this decimal right here, let me switch colors to something that looks a little different. This one is going to go 2 places, and it's going to be 3 because the decimal is right there now, so it's going to be 3j. And that's going to be equal to, we're going to move this 2 places. So you're going to go once and then again. Now this is a placeholder, so we're going to have to put a 0 in there, and the decimal goes right there, equals 60. And now this equation is a one-step equation. We just divide by 3 and we are finished. J, the solution, J equals 20. Let's take a look at the problem on the right. Remember that however many places is the largest number of places, that's how many places we're going to have to move it. So let's count. This decimal here, to make the decimal disappear, would take 1 place. This number here will also take 1 place, and this one also takes 1 place. So this is pretty simple. We're just going to move every decimal 1 place. So instead of 2.5, that number is now going to be 25 minus, and instead of 0.4, it's now just going to be 4y equals, and this number is going to be 61. So now we're down to an equation with no decimals at all because we moved it. We cleared the decimal, and then we always are going to do our adding and subtracting step first, which is to get rid of that 25. And that leaves me, don't forget the negative sign, please. Don't drop those, negative 4y. And when we take 25 away from 61, we're going to get 36, positive 36, and then we got to divide. You know, that last step is to divide, but we got to divide by that negative 4. Don't forget about that. Don't forget about writing it down. Let's reduce the negative 4's on the left. And we get y equals negative 9. And there is your solution. Negative 9 will make that true. I thought I'd take a moment and split my screen up a little bit. You can see over here that I brought in the Desmos calculator. We're going to actually check this problem to make sure that negative 9 is the correct solution. Remember that if you're a solution, if I put you into the equation, you should make the equation true. But I'm going to go ahead and type in this original equation. And so I'll use my window on my calculator. So that was 2.5 minus 0.4 y, and whenever you see a variable, we're going to go ahead and use these parentheses here, and I'm going to put the value of y right in there. Let's put the rest of the equation first. Equals 6.1. Now you'll notice that it's giving me this little triangle and exclamation. It means it doesn't know what I'm asking it to do because it doesn't know what number goes in the parentheses. I'm going to put a negative 9 in there. Notice I typed in the equation exactly as I see it. 2.5 minus 0.4 y, and the y is what's left with those parentheses. And now I'm going to put a negative 9 in there, and we just want to know, is it true? And actually, I guess I should take away this 6.1 because I already know what it equals. I know it equaled 6.1, and so you can see that 2.5 minus 0.4 times negative 9, that came out to 6.1, and the right side was also 6.1. So that means that when I put in a negative 9, the left side equals the right side, and that's why it's my solution. Okay, let's take a look at this example here. This is maybe one of the other complex examples. There's one other issue we need to resolve. Let's count decimal places first because we're going to get rid of the decimals. This number you can see has 3 decimal places. How about this number here? If you move it all the way over past the 2, it's got 2 decimal places, and this number also has 3. So we got to pick the largest of them, which is 3 decimal places. So we're going to go ahead and move it 3 decimal places. And if I move this number 3 decimal places, it's going to go right there. And this is going to be a 13. You don't need to write the extra zeros. So it's just 13 minus. And if I move this 2, I got to move it a 3rd place. So that means I'm going to need one more number, and I'm going to need an extra 0 in there. And that's going to give me minus 20g. A lot of times kids will just stop at the 2 because they're like, well, I'm out of numbers. But no, you got to go that 3rd decimal place and add a 0 because everything needs to be moved the same. And we're essentially, when we move the decimal 3 places, we're really multiplying every term by 1,000, which is just like the lowest common multiple in fractions. We're just counting decimal places. And this one over here becomes 53. And right now I've got an equation that has no decimals. And it's pretty simple. So the next step is to add or subtract. I'm going to go ahead and go through this one pretty quickly, but we'll take away the 13 because that's the opposite of that number. And don't forget the negative sign in front of the 20g. And 53 take away 13 is 40. And when we divide by a negative 20, we will get that g equals, as a solution, negative 2. And I have the calculator right here ready to go. Let's go ahead and plug that in. I know that the right side is expected to be 0.53. So let's go see if the left side gives me 0.53. 0.013 minus 0. Let me take that out, 0.02. You don't need to put those zeros in front of the decimals for the calculator's sake, but I do it because that's what we're looking at. I'm going to use parentheses here because that's what g is. G is going to be a negative 2. So let's go ahead and put a negative 2 in there and see if we get 0.053. So you can see that the left side is 0.053 and the right side also had 0.053. That's your solution. Let's go ahead and box it and we'll wrap that problem up. Hey, I wanted to pick one more problem just to illustrate one other issue, and this one seemed like as good and confusing as any. So we're going to continue to clear decimals. Let's take a look. This one number here, this first term, 2.25t, has 2 decimal places. This 5 here has 0 decimal places. This 13.5t only has 1, and the 14 also has 0, and you've got to pick the number with the largest number of decimal places. So in this case, it's 2 decimal places. So we're going to move every number 2 decimal places. We're going to move this guy twice, and that's going to give me 225t. We don't need to be confused or scared about the big number. It's okay. But this number doesn't have any decimal places, and some people don't know where to start sometimes. The decimal is right in front of the 5. That's where it is, and we got to move it twice. And when I move it twice, that number becomes 500. So plus 500 equals. Now this number has to get moved twice as well. And if I go past the 5, that's only one place. So I got to go again and put a 0 in there. And it's 1,350 t if I move it 2 places. And then again here, got to move it twice. Once, twice, and there's 2 extra zeros plus 1,400. And now I've basically got variables on both sides. We're going to move the smallest variable first, 1,350t, 225t. This is the winner. This is the smaller one. This is the one that gets to be moved. So I'm going to take away 225t on both sides. And I'll draw my line. So let's do a quick bit of subtraction. Let's clear up our sides here. I'm only left with 500 on the left equals, and let's go ahead and borrow here and do the subtraction. We're going to end up with 1,125t plus 1,400. We'll go ahead and take away the 1,400 on this right side. And that's going to leave me, if you want to use your calculator, you can. I actually have the calculator hidden behind that window, and I'll bring it out in a second. That right there is going to become a negative 900 equals 1,125t. And at this point, we're going to divide by 1125. And you know what? You could reduce the fraction. It looks like a 25 will go into all of it. And you could make it simple. At this point, I would rely just on my calculator. So I'll go ahead and pull it up here, and let's get that number done correctly. We have a negative 900 on top. I'll use the A over B button. We have a negative 900 on top, and we have a 1125 on the bottom, and you get negative 0.8. So t equals negative 0.8. If you were asked as a fraction, that would be negative 8/10 or negative 4/5. And yeah, you could reduce it if you want. If it was me, I wouldn't do it. I'd leave it as a decimal, and that is absolutely fine with me because we showed all our steps and we're good to go. All right, let's take a look at a word problem. These word problems are going to be very similar to the word problems in 7.1. We're almost always trying to compare two quantities, and that's the whole point of having an equation when one side equals the other. And we look at this, and I see the phrase cost him the same amount, which tells me something's going to be equal. And let's go read the problem for understanding. It says George is going to the Butte County Fair, and they charge admission to the fair, but they have two separate options, and that means we're going to be comparing one option and another option. Option one tells us this, here it is. Option one charges an admission fee. When you go to the fair, you usually only pay an admission fee to get in, and you only pay it one time. So we don't pay it depending on how many rides I'm going to go on or how many exhibits I'm going to visit. I just pay $1.75. So if I go under option one, I'm going to pay $1.75, and usually means plus. So $1.75 plus. Rides cost $2 each. Well, $2 per ride, and all of a sudden I see cost the same amount, and I see what's the question. You know, we always want to know what's the question. And there it is. How many rides? So when I see the phrase, how many rides, that means I'm using R. I need to know what that is. And it says rides cost $2 each. There's rides, there's my R, and it's $2. So it's plus 2R. And you could call it 2.00R if you want, and I'm probably going to end up doing that, right? I'll just write it below. I know it's $2 per ride. I'll give it 2 decimal places because this has 2 decimal places, and most money problems have 2 decimal places. Option 2 charges an admission fee of $8. Gosh, you pay a lot more to get in, but then look what happens to the rides. They're pretty cheap. So I pay that $8 admission fee. That's not where my letter goes because it doesn't say I pay $8 per ride. It says I pay 75 cents per ride, and that's my R. So it's plus 0.75 R. So seeing the structure in the equation is really important. We pay $1.75. That's my admin fee. And this right here is my admission fee, cost per ride. Now we're going to solve it for R and find out how many rides it would take. Let's count decimal places. 2, 2, 2, 2. We're just going to move it over twice, and we have 175 plus, and this will be 200R equals, and that's 800 plus 75R. And I would say this, you could probably solve this without moving the decimal points and just leaving the decimals in. It's a money problem and the numbers are pretty simple, but I think it's good practice to clear decimals and get used to having good equation solving techniques. Plus a lot of kids will miss decimal points, not line them up correctly and understand place value, and then make silly errors. Let's take a look. Which one of these variable terms is smaller? I have 200 and I have 75. So we'll go ahead and move the 75. It's smaller, and that will ensure that I'm working always with positive variables. So the 75R is gone. 800 is all that's left on the right, and that's 175 plus 125R. Last step is to solve a two-step equation. We're going to do the subtraction first. Take away 175, and that leaves me with 125R equals, and that's going to be, if I borrow from the 8, 625. And when I divide by 125, you could use your calculator if you want. 125 is going to go into that number 5 times. So in this case, R is 5, and it's a word problem, so we always want to write a sentence. Let's answer the question. How many rides would I have to go on for the options to be the same? That means if I go on 5 rides, this over here is going to cost something. If I put a 5 in there for R, and I use my calculator, 5 times 2 is 10, plus $1.75, that'll be $11.75. And a 5 times this right here, if I put a 5 in there, 5 times 75 cents is going to be $3.75, I think. Plus 8 is also $11.75. You can use your calculator to check it. After 5 rides, both options cost the same. And that's it.